Hello everyone. In my previous video on permittivity, we found out that permittivity qualitatively gives the resistance of the field penetration in the medium. But when we talk about electrostatics, we also come across this quantity called susceptibility. So, why do we need another quantity called susceptibility? That is what we are going to discuss in this video. If you consider an atom or a molecule in the absence of an electric field, then the center of the electron charge distribution and the center of the positive charge distribution from the nucleus, they will coincide. So it will not have any dipole moment. But the moment we place an external electric field or we apply an external electric field, then the atom the will have a dipole moment because the center of the positive charge distribution and the negative charge distribution, they will be separated. So we'll have a non-zero dipole moment. When we place a dielectric medium in an external electric field, now the atoms or molecules which is consisting the dielectric medium, it will have an induced dipole moment. And all the dipole moments will sum up to give a net dipole moment of the medium. This is a schematic diagram of a dielectric medium when it is placed in an external electric field. So because of the induced dipole moment, we will have a net dipole moment for the medium. Now, if you consider this portion, and you can see that the net charge inside this dash portion is 0. Let us exclude this net zero charge portion of the dielectric medium. So when I exclude this, we can see that on the surface of the dielectric medium, there is a induced charge. On one side it is negative and on one side it is positive. So because of this induced charges, it will generate an internal electric field which is opposite in direction to the external electric field. So inside this dielectric medium, the net electric field will be lesser than the external electric field because the induced electric field is in opposite direction. So if you see carefully, because of the external electric field, there is an induced dipole moment, and this induced dipole moment, they contribute to the net dipole moment, and the relation is given by this formula. So we have two phenomena happening here. One is the creation or the generation of a net dipole moment due to the external electric field, and the other one is the reduction of the net electric field inside the dielectric medium. So using these two concepts, let us now define what is susceptibility and what is permittivity. So susceptibility, it's a measure of the polarizability of the material, and permittivity is the total response of the medium to the electric field. We can say that susceptibility is the tendency of the material to get polarized, which is the underlying cause, while permittivity tells us the overall effect on how the electric field behave in that medium. Now, the relation between susceptibility and permittivity is given by this formula. Let us consider two medium, one vacuum and other one dielectric. So for the vacuum, the permittivity will be epsilon naught, and for dielectric, it will have some permittivity value. But what about susceptibility? Now, vacuum in classical sense is an empty space, so there will be no polarization. So since there is no polarization, the susceptibility will be 0. But in the case of a dielectric, polarization will happen, so the susceptibility will be non-zero. And suppose if this dielectric medium has a susceptibility value of 2, then we can say that this dielectric medium gets 2 times more polarized than vacuum under the same field, because vacuum has a susceptibility of 0, so we can take that 0 value as the reference. So in a dielectric medium, because of susceptibility, it will lead to polarization, and because of this polarization, there will be an induced electric field, and the total overall behavior of the electric field in the dielectric medium, this is represented by the permittivity. Now, we can say that susceptibility is the cause and permittivity is the effect. And this induced electric field, this can also interpreted as the storage of electrostatic energy. Now, we have been talking about dielectric. What happens in the case of a conductor? In the case of a conductor, this chain of process, it will fail. In the case of a conductor, there are free electrons. So when you place a conductor in an external electric field, these free electrons, they instantly arrange themselves such that the induced electric field is equal and opposite to the external electric field. So there is no polarization happening. So it doesn't make sense to define a susceptibility for conductor. But when we use high frequency signal, then in addition to the conduction effect, there will be a delay effect, because the free electrons will not be able to follow the changing electric field. And because of this delay effect, there will be loss. And because of this loss, the permittivity of a conductor in high frequency signal will be a complex quantity. What about dielectric in high frequency signal? So when you place a dielectric in a high frequency signal, there will be polarization as well as there will be dipole oscillation. And because of the high frequency, there will be also delay or loss. So because of this three effect, the susceptibility of dielectrics when placed in a high frequency signal, it will be a complex and frequency dependent quantity, and because of this, the permittivity will also be a complex and it will be frequency dependent. Thank you everyone for watching this video. Take care.